Okay, this video is going to be about how to calibrate a lockout machine or a crank machine. All crank machines are lockout machines, which means when they pull tension, the moment that the spring tensioner senses the tension has been achieved, the mechanism will lock out. It will neither go forward nor back, which is a little different than in a constant pull machine. Drop weight machines are a constant pull machine, and electronic constant pull machines pull and adjust. A drop weight, obviously gravity never changes, so as long as gravity is pulling down on the drop weight bar, as the string relaxes or loses tension, the bar will continue to fall a little bit, which doesn't mean you're losing tension, it just means it's compensating as the string is stretching. Electronic constant pull machines do this mechanically through load cell sensors in there, and it'll pull, and when it achieves the tension it stops pulling, but then as the tension starts to drop on the string that's being tensioned, the tension head will pulse slightly, making little incremental changes to keep the tension up, because otherwise the tension will drop. So I had to go dig out my lockout crank out of where it was being kept. So I'll be putting this on the machine, and so before I do that I realized that I might as well kill a couple of birds with one stone, or one video. And before I put that crank tensioner on here and show you how to calibrate it, and how that is a little bit different process for calibrating a lockout machine versus a constant pull, whether it's an electronic constant pull or a drop weight, it's going to be a little bit different as to what you're looking for on the actual calibrator itself. There are graduations. There's pounds on one side, kilograms on the other, but there's incremental marks, and if you're looking at pounds, it's every 5 pounds, 10, 15, 20, and so forth. So those are sort of the numbers that you want to use when you're doing the calibration, and you want to be able to see the little line just barely. And if it's a constant pull machine, you want to still be able to see that line. So for a drop weight or an electronic constant pull, if you pull 50 pounds, you should be able to see the little white line just barely here on the bar. When you're pulling 50 pounds, it should stay there. Hence the name constant pull. On a lockout machine, when you pull this, you're going to see that same white line, but a lockout machine is, like I said, it's going to pull, and as soon as it achieves tension, the mechanism locks out, and it'll neither go forward nor back. So as the tension drops on the string that's under tension, this is going to drop. So when you calibrate a lockout machine, you're only looking to see that line at the very moment of lockout. If you wait a number of seconds, or 20 seconds, 30 seconds, this is going to be going down slowly. The white line that you could see in that brief moment when you achieved lockout, you may not be able to see that line if you are looking at this 5, 10, 15, 20 seconds after the fact. So you want to be staring at this when you're calibrating a lockout machine right when you achieve lockout. In other words, when your brake releases and it locks the mechanism on the track, that's when you want to be staring at this, because that's the only moment that matters on a lockout machine. You don't have to be in a rush to see this with an electronic constant pull or a drop weight, because you should be able to, you want to see that line there constantly. And I'm going to give you a better visual representation of how to see, not so much see. I want you to understand how strings relax, which affects the calibration reading later. So we'll come back to the calibration, and I'm going to set this up. Like I said, I'm going to kill a couple of different topics here in one video. But because I have a Weiss electronic tension head on my machine, to do this video, I obviously have to take this off and put the crank on, and then later on I'll take the crank back off and put this on. So I might as well cover a very, very common question, which is how easy is it to I'm considering getting a Weiss tension head. People often ask, and they say, how easy is it to put on my machine, my crank machine? It's very, very easy. So let me put the calibrator down for a moment. And I want to show you how to set up your machine for the purposes of calibration. So we're not using the calibrator just yet, but this is how you test tension, and we will be using the calibrator in a few moments. So the first, I've got the machine set to 55 pounds right now, and right now it's on electronic constant pull. A Weiss tension head has the ability, with this button here, you can take it off of constant pull, which means it's now like a lockout machine. So it'll pull tension, and as soon as it hits 55 pounds, it won't make any compensation. It will no longer pull those small little increments that it does when it's in constant pull mode. So it'll just go to 55 pounds, and then as the string relaxes, that tension is going to drop. And I'm going to show you that in a moment. And I'm also going to show it to you with the constant pull feature on, so that you can see how it maintains that 55 pounds. And I'm not going to do it with the calibrator just yet. I have my calibrator set up with Kevlar string, which has the least amount of stretch. So to get the best readings, it's a good idea if you have some Kevlar to put Kevlar string on here, or whatever's the lowest stretch string you've got laying around. Some calibrators don't come with a string attached to them. Some of them will have string on there. It's usually cheap nylon or whatever. But keep in mind that the strings that are attached to the calibrator themselves are going to relax and slightly alter your readings. So if you've got some Kevlar, put some Kevlar on there. If you don't have Kevlar and you've got a thick, stiff polyester that doesn't stretch very much, you know, some 16 gauge stiff poly, maybe put that on your calibrator as opposed to just putting some synthetic gut or some nylon on there, which can slightly affect the reading. So this is Kevlar, and the reason that I'm not showing you right now is this is not going to drop, the tension is not going to drop on this very fast because I have a very stiff, or not stiff, but a super low elongation string, Kevlar string attached. So right now, if I were to demonstrate using a Kevlar string, you wouldn't see this tension drop very much. So I'm just going to show you a quick example of how to set up the turntable for when you are using the calibrator, but I'm just going to use a regular piece of synthetic gut string as well as a piece of polyester string to show you the difference between how electronic constant pull or any kind of constant pull behaves versus a lockout where the tension will drop. So you want to turn your turntable sideways, and if you have a turntable lock, it's a good idea to lock it. Because you want to orient, you basically set up your turntable like you're pulling crosses. You don't need a racket mounted or anything like that. You don't want you run the string through any grommets or a frame at all, because that's going to introduce friction into the system and not give you the most accurate reading. So we don't use a frame, we don't run the string through anything. So orient your base clamps. Now if you have a glide bar machine like a Prince Neos 1000, turn it this way and turn the glide bar so that it's oriented like you're pulling crosses, and line up your clamp with your tensioner. But if you've got a swivel clamp machine like this, you want to take your swivel clamp. Let me turn the turntable for a moment to show you this way. So for a moment, pretend like I'm going to be pulling tension in that direction. I want to take my base clamp that's on the far side. So this base clamp that's further from my tension head, and I want to point it, I want to orient it in the direction it's going to be pulled, like this, and I want to lock the base. And again, I would lock the turntable, but for clarity, I realize this might be in the way. So basically, I'm going to be pulling, I'm going to lock a string in here and pull this way across the turntable. Now the reason that I'm choosing to use this base clamp that's on the far side of the turntable and not this one here, which is closer, you might be thinking, well, can't you just orient this one the same way? Now the reason that I'm pointing this part of the base clamp at the tension head is when there's tension pulled on this, even though this is going to be locked in position, I don't want there to be any possible twisting of the base clamp in the track. And so basically the path of least resistance, if we don't have the base clamp locked at all and we pull it this way, it has nowhere else to go but to line up. And we will lock it. But if I use this base clamp that's closer to the tension head, there's nothing supporting the underside of it here, and so there's a small risk of it getting pulled downward when I apply tension and flexing. So by putting this one over here, I have turntable directly supported underneath the clamp. So that's why I'm using the one that's on the far side. So I've locked this base clamp, I've put it in the center of the turntable. Again, it would serve no purpose to put this way off to the side, one way or the other. So you want to line this base clamp up with the center of the turntable, and you want to align this portion of the base clamp in the direction that you're going to pull, and then lock the base clamp. So now that we've got this oriented properly and locked into position, we're going to put a string here and pull tension over here. So this is just a 16, or I don't remember if it's 16 gauge or 17 gauge, but this is just print synthetic gut with Duraflex. And I'm going to clamp that. Obviously adjust your clamps. So we set this up, point it in the direction of the anticipated pull, lock the base clamp, and adjust your clamp for whatever gauge string. So if I lock this into place, and I'm going to back that up with a starting clamp. So I'm going to go ahead and put a starting clamp behind that, just in case it should try to slip. And now I'm going to lock my turntable into place. So now when I pull tension on this synthetic gut at 55 pounds, you're going to see, and right now it's in constant pull mode. So when I hit 55, when this digital readout hits 55 pounds, you'll see that it's going to maintain that. So right there it's bouncing a little bit. It's at 55.0, 55.1, 54.9. I think it goes, once it drops, I think it's maybe 0.3 below whatever you have it set, that it'll make a small pull. So I suppose if we've got it set at 55 pounds, 55.0, I think when it hits 54.7, that it makes an adjustment and goes back up a little bit. And you might be able to hear the tension head periodically pulling, and that's because this string is relaxing. If we didn't have it in constant pull mode, these numbers would be dropping instead of staying for the most part at 55. So that's what synthetic gut does, and in electric or in constant pull mode. So let's take a look at how differently things are. If you take it out of constant pull mode and you put it now in lockout mode, that's going to pull and go all the way up to 55 pounds, and as soon as it hits 55 pounds, this tension mechanism is not going to move anymore. And because the string will be relaxing, you'll see these numbers start to go down. So it'll hit 55 for a moment, but then they'll immediately start to drop. So we'll show you with the synthetic gut. So now it's at 51.4, 50.8, 50.4, 50.3, 50.1, 49.9. And the longer we wait, the more that number is going to drop. So if we wait 10-15 seconds, you can see how quickly this string is dropping in tension. You can't see it when you're looking at it, but this shows you over here that it's now at 49.0. And if I wait a little longer, it'll drop a little further. This is why if you're working with a lockout machine, a crank machine, that as soon as your crank mechanism reaches lockout, you want to move the clamp and clamp off the string relatively quickly. You don't want to dawdle, you don't want to wait, because the longer you wait to move the clamp, once you've achieved lockout, the longer you wait, the more tension you're losing before you get it clamped off. So with a lockout machine, it's important that you crank kind of slow. You want to crank at the same speed all the time to keep things nice and consistent, but whenever you hit lockout, try to briskly get over there and move the clamp straight away from its previous position to the new position. So you can see now that this is down to 48.2 as the string relaxes. Now I've shown you this with synthetic gut because now I want to show you with polyester. For those of you who aren't familiar, not all strings maintain their tension at the same rate, and polyester is renowned for having a very quick tension loss. So I'm going to remove the starting clamp here and this synthetic gut, and I'm going to show you the same thing with a piece of polyester string, because the tension drops on polyester even faster than synthetic gut. Natural gut has the best tension maintenance. So when you hear things like when you're shopping for strings and you're looking for good tension maintenance, now all polyesters are, almost all polyesters are not known for having good tension maintenance. That's one of the downfalls of polyester. There's pros and cons to every string, and one of the big cons of a polyester string is it doesn't maintain its tension very well. That's why you don't want to play with a polyester string in your racket for 3, 4, 5, 6 months. Polyester strings, they don't really break that fast, because it's such a robust material and it's slippery and it slides on itself, and it's good for spin if you have a spin generating stroke, but it's not good for tension maintenance relative to other strings like multi-filaments or natural gut and things like that. So when we clamp off this piece of polyester string and we apply tension to it, the same thing's going to happen as it did with that synthetic gut. The tension is going to drop because I still have this in lockout mode. It's not in constant pull. Obviously, if I turn the constant pull on and we pull it at 55 pounds, it's going to go up to 55 pounds, and as the tension drops on the string, it's compensating and making micro adjustments and small little pulls to keep it at 55. But if I turn the constant pull feature off, which puts it back into a lockout mode, which is exactly like a crank machine, once this hits 55 pounds, you're going to see this number just plummet. So that advice I just gave you a moment ago about if you're using a crank machine and you pull tension, you want to swiftly move your clamps, even more so when you're stringing polyester, because the tension drops on it even faster. So you'll see it hit 55 pounds, but then the numbers will immediately start to plummet with the polyester. 49.0, 48.2, 47.7, 47.3, 46.9, 46.3, 46.0, 45.8. So you can see in just a matter of, what, 10-15 seconds, a string that you thought was at 55 pounds is suddenly at 45 pounds. So this is why you want to clamp off your strings really quick when you're working with a lockout machine. But I wanted you to see this tension drop so that you understand with the calibrator, when you see the white line at a certain tension, let's say you're pulling at 50 pounds on your calibrator to test your tension, you're only going to see that line for a brief moment when you're using a lockout, because the string is going to relax. Now obviously if you use a low stretch string like I advised, in this case I'm using Kevlar, it'll minimize that. If you're using a calibrator on a constant pull machine, you should be able to see that white line ongoing. So this explains why. So before I release tension, you can see that a string that this polyester string that we had pulled at 55 pounds is now down to 44.6. So tension drops really quick on strings. That's one of the reasons why they created constant pull machines, is so that the string is still at 55 pounds by the time you're clamping it. So now I'm going to set it up with the actual calibrator. Now I'm going to take the Weiss tension head off and put the crank on here. There's only one screw, it's a hex screw, that is holding this onto the tensioner bar. So let me turn this off. So I've got a hex wrench here. There's one little screw on the bottom here. I know that you can't see that on the camera, but that's all I have to loosen. So this part now answers how easy is it to swap out the crank for the Weiss tension head, or if I'm going to buy a Weiss tension head, will it be easy to install? It's very easy. I think they might use 2 screws now, where I'm loosening. Mine just has 1 screw, but I think the more recent models may have 2 screws on the bottom of the bracket, which I'll show you after I get it off. So there's just 1 screw, and then the whole unit will slide right off of the end of the bar. So there's your tensioner, and there's the bracket, and there's the single screw, hex screw, that holds it onto the tension track. So let me set this down, and now we'll go ahead and put this on. Now, I don't have on a Gamma machine, to my knowledge, all Gamma crank machines are going to be the same. The tensioner is essentially the same tensioner. The way you calibrate it will be the same. And the end of this track bar, there is a little tiny screw here at the end, a little washer and a little screw, Phillips head screwdriver. I'm sorry, Phillips head screw and a little washer, which I don't even have in place there. because sometimes I have to travel and take the Weiss head off. I don't want to have to fool with that every time that I want to put the Weiss tension head on or take it off. So right now that's not there, but normally you would remove this you would take the screw out of here in the little washer and just uncrank this and it would come off the track. So now we're reversing that, we're putting it back on there. So you just slide this on. Obviously it's got wheels that line up. Now if you have a gamma machine, before we get into the adjustments and the calibration and everything, I know you can't see it from the camera angle, but there is a little knob in this spot on the back side. And what this knob does is it creates a stop. I'll show you. When you slide the tensioner on, first I'll do it without carrying the relative position of the handle. So once you have it on there, this will go back and forth. Now this knob that's on the back side has two positions. The position it's in currently allows this crank to go beyond that knob. In other words, it'll go all the way to here. There's nothing preventing it from crashing into a frame if there was a frame mounted here. Nothing stops it. And when you put the Weiss tensioner on, you need the knob in this position. Otherwise, if you turn the knob 90 degrees, it's a little spring-loaded knob. Its intended purpose is to, when you have this stock crank mechanism on there, is it prevents this from going too far forward into the racket that is mounted, and it also creates a stop so that every time you tension a string, the distance from the racket to the tension head remains the same. If you don't have this engaged, then this will continue to travel right up against the racket if you wanted it to. And there's some machines that don't have this kind of a stop mechanism to prevent this from going over. So like a Prince Neos 1000, you can get the tension head all the way up against the frame. You can bang it into the frame. I've seen lots of frames that have damage on them, usually near the throat, from where someone has spun a racket around and it has whacked into the gripper on a Neos or a similar machine. So if you have a gamma machine, it's a very good idea when you're using your crank to engage that knob so that this will stop at the same spot every time. This will give you more consistency because again, the string length that's going from the racket to your tension head remains the same every single time. Now, you'll notice that this handle, I did not pay attention to how this handle was oriented when I fed this onto the track. I wanted to show you that there's an adjustment that you can make. If I let go of this, the weight of the handle is going to make that swing back. So right now this is not pressed up against the stop. And if I let go, it is when I keep pressure here, but the weight of the handle is going to make that move away from there. And that's not really where I want it every time. I want it to be up against the stop and not go backwards. So you want this handle to be on this side so that the weight of the handle keeps it pressed against the stop, or have the handle at the very bottom. And the way to do that is take this back to the end of the track so that the cog on the inside disengages from the teeth here on the bar for a moment. And I've found that if you start with this handle down here, if we think of this as a clock face, if you position this handle down here around 5 o'clock, 4 o'clock, 5 o'clock, at a slight angle, and you get the cog to engage the teeth on the track here with this at this position, like so. Then when you advance it forward, you'll go all the way to the stop. This will rest up against the stop every time, and your crank will be at the bottom, and it's very easy when you're cranking it, assuming you're using your right hand, to just reach down here and go, and it'll lock out. And then back. Lock out, and then back. So you've got the tension mechanism returning to the exact same position up against that stop every time you release it. So that's how I would have you line it up. So I mean, some people might want this at the bottom. When I have it on here, I like this to be at the bottom, but this could be here as long as this is up against the stop. You know, if you want the handle to start there, but you just don't want the handle back here because the weight of it is going to make that swing backwards. So we're going to start with it there. Now, let me go ahead and show you how I set up the calibration, the calibrator. It's the same way that I did with the string, and I know that you can't see the knob and the scales that are on the back of this, so I'll have to move the camera a few times. So let me switch this out. We'll get rid of this actual tennis string. So here's my calibrator. I'm going to turn it this way so that I'll be able to see the pounds and the numbers, or you will from your perspective. Right now I'm looking at everything upside down, but I would normally be where you are. And I'm going to put this piece of Kevlar string. Now this is a very thin Kevlar string, so it's a very good idea to be backing it up. Once I put it into the clamps, I'll be backing it up behind the clamp with a starting clamp. So I'm going to actually put my starting clamp here, and I even have a little knot here, but you don't have to do that. So I'm going to feed this. Let me turn the turntable so you can see a little better. So I'm going to use this one. I've got this clamp adjusted for the very thin Kevlar. So just like before, we're going to load the string in here, clamp it, and it's backed up with the starting clamp here. And I'm going to take this base clamp and point this side of the base clamp in the direction of the anticipated pull, which is going to be this way. And I'm putting it in the dead center of the turntable as well, because if you lock this off center and you don't have you can see how the turntable is going to want to pivot. So you want to put this in the middle, lock it in place. This will naturally swivel to be straight. And so now when you tension this, the turntable doesn't want to spin and swivel all over the place. And again, if you have a turntable lock, go ahead and lock it so that everything stays nice and still here. So that's the kilogram side, but if I rotate it around, we should be able to see the pounds. I'm going to go around the roller guide here, and I might have to tip this to be able to see it. And I'll zoom in and show you what we're looking for here in a moment, but I just want to show you the setup here. So basically, we've got the calibrator suspended between a clamp, which is locked and centered in the turntable, backed up with a starting clamp, and over here, I'm going to put this in the gripper, and it's probably not a bad idea for me to go ahead and put another starting clamp right behind the gripper plates as well. That's just because this is very thin Kevlar, and I don't want to have to go adjusting my gripper just to grip such a thin string. And so now when I pull tension, so let's say I have this set at, I think right now I have it set at 40 pounds. So when you crank, notice that the brake hasn't popped yet. As I'm pulling this up, that's when I want to be looking here at the side that shows the pounds, and my eyes need to be here as the handle reaches lockout. And so right there, I can barely see the line, the white line, that is where the 40 mark is. Because the longer I wait, so if I wait right now long enough, I won't be able to see that white line, because these are going to slowly, this is going to recede inside of the calibrator as these strings relax. Now again, I'm using Kevlar strings, so they're not going to relax very fast. But if your strings that are attached to your calibrator are synthetic gut or nylon, you want to be looking at that right away as soon as you achieve lockout, because otherwise this is going to slowly change. And I'll zoom in on this in a moment, and I'll get the camera to show you what the scale looks like on the back, and then how to go through the calibration process. So let's release this. So that's basically how we're going to do it each time. So I don't have to mess with anything here. So each time we make an adjustment, we'll be rechecking the tension like that. And we'll be looking over here. Okay, so right now I haven't changed anything other than zooming in and repositioning things so that you can get a very clear look here at the calibrator. One side is kilograms, one side is pounds, and I haven't changed anything on the crank where the tension is set. It's still set at 40 pounds. So I'm going to pull tension, and just before it achieves lockout, I want to rotate this so that I can see the markings here on the side that has pounds. And for a brief second, you should be able to see, you won't be able to see the 4 and the 0 for the 40 because the little white line, the mark is right between the 4 and the 0. So you'll see the 4 and you'll see the white line just barely because it's going to be almost flush with this piece here. So be staring right up against there. So right now, before there's any tension, you can see that there's, that's actually the mark for 10. If I pull on this a little bit, you can see that there's a 1 and a 0, but the little hash mark is between the 1 and the 0. So when we pull it up to 40, you're going to see the 4 and that little white line. So it's going to look just like that, except that's going to be a 4 there instead of that 1. So go around my roller guide into my gripper. So now I'm cranking slowly, and now my attention is over here. So I'm going to pivot this. I don't really want to push up or down on this to increase the tension on it. I just want to spin it a little bit so that I can see the, if it doesn't already say pounds, you're going to have to rotate it so you can see it. So as I get close to achieving the tension and coming close to lockout, that's when I turn it and watch for a moment there. You can see we're about 30 pounds, and when the brake pops out, you'll see the 4 and the little mark. And it's pretty much staying there, but again, that's attributed to the Kevlar string that I've got attached to the calibrator. If I had a nylon string on there, and if I leave it long enough, you may not be able to see that little white mark there that's below the 4, or between the 4 and the 0 on the 40. But that's basically how you want it to read. So if you've got your tension head set at 40 pounds, and when you do this test and it's right there on that line, when you hit lockout, that's exactly how you want it. And of course you can change it. So let's say I go up to 50 pounds. So that's 40, so that's That's 45 right there. So let's see. I think that's 45. I'm looking at everything upside down. So this should hit 45 at lockout. And if we go up to 50, so that's 48, 49, that should be 50. And let's take a look. So it's really close. And I'll calibrate it here in a minute. So the previous videos, they showed how to check. They've done what I've shown you thus far, but they didn't actually make any adjustments on their tension head because I guess it was close, it was already calibrated. So I'm going to intentionally put mine out of calibration, and we'll rectify that and put it all back to the correct adjustments. So let me zoom back out. So now that we're zoomed back out, I'm going to show you how to set things up on the back of the tensioner. I'm going to intentionally uncalibrate, if you will, the tension head. I'm going to have it intentionally be, 10, 20 pounds off from what the actual reading is here. So in other words, let's say I think my machine is set at 50 pounds, yet over here it's really only pulling 30 pounds or 40 pounds or maybe 60 pounds. Maybe it's an overage instead of under. So I'll intentionally take this out of calibration and then show you how to do that, those adjustments, because that's the part that to my knowledge, there isn't a video out there where anyone was showing that whole process. So this is the back side of the tensioner, and the stop knob that I was referencing a moment ago is right here. Like I said, it just changes positions 90 degrees. So if you have it positioned this way, it will not stop anything, and it must be like this if you want to put a Weiss tension head on. Or you can have the Weiss tension head further away, so I shouldn't say that it doesn't have to be this way for the Weiss, but when I position my Weiss, I like my Weiss tension head close to the frame, so I position it like this. Or if you don't want, for some reason, if you didn't want the this pin to stop the crank, it'll go beyond that point. But again, it serves a good purpose, and if you're using the crank, you might as well have it stop at the same spot for every pull. So, again, I've got it positioned so that my crank handle is oriented down as it comes to come to rest against the stop. So that's what the back side looks like, and there's that knob that I spoke of before. So let's focus in here on the knob, which also has a 0, a 1, a 2, and back to a 0. That's how you get other increments here. So let me focus in on this scale so that you can see what's going on. Okay, so now we're zoomed in on the scale here, and you just turn the knob to move the marker from anywhere from, I believe this machine goes from, I think, 8 pounds all the way up to 90. But for the purposes of calibration and so forth, you're going to pick nice even numbers like 20, 25, 30, 35, 40, basically the same markings that are on the calibrator itself. And you can see the little white line here that moves as I turn the knob to change the tension. Now, the little marker that is moving here is a little bit wider than the actual hash marks here where the numbers are. So I'm just going to be focusing over here where it says pounds, and I'm going to be ignoring the kilograms. So for example, if I put this, I would say that this is 30 pounds right here. Basically, I try to put the center of the white mark that's moving in the center of the hash mark where the 30 number is. It doesn't really matter as long as you're consistent with it. Someone once said, well, it's, you know, that line is wider than these lines, so who's to say where it's correct? Do you go by the front edge of this moving indicator? Do you go by the back edge? Do you split the difference, which is essentially what I do? It doesn't really matter because you're going to calibrate it so that it'll be 30 pounds. You know, if you want to go with by front edge or by back edge or the center, that's up to you. But it'll be the same all the time as long as you always set it the same. So when you go to change it to 50 pounds, if you, let's say you've decided the front edge of this marker is going to be your indicator, so you're going to put the, so it'd be more like this. So like, let's zoom in a little bit here. So let's say you decide you want the very front edge of that to line up like that, and you're going to call that 30. Well, that's fine. That's just as long as you do that every time. So let's say you wanted it to be 48. You're going to do the same thing and line up the front edge of the moving piece with 48 like so. Like I said, I usually do, I think of it as the center. I just try to centralize the moving indicator. So for me, I would call 30 right about there. So again, that's up to you. Everything else will get adjusted so that 30 will be 30, 40 will be 40, 50 will be 50, etc. as long as you always line it up the same way. Now, let's zoom out a little bit. Okay, I'm not shooting straight down on this. I've got the camera angled as straight down as I can get it without it being a problem. But I've got that set at 30 pounds right now. And you'll notice that, and when I have that set to 30 over here, I want this marker to be lined up with the 0 on this collar, and right now it isn't. So this is the first thing you want to adjust. So you want to loosen this set screw right here. This is a 2.5 millimeter wrench, hex wrench. So I don't want to turn the knob because I don't want to turn the knob here because I don't want this indicator to move. I just want to loosen this, and once this is loosened, so by loosening this set screw just a little bit, because all that set screw does is keep this collar with the 0, the 2, and the 1 from spinning around. You'll notice that even though I've loosened the set screw, or even if I were to remove it altogether, I'm not going to do that, but here I've got it backed out pretty far, you'll notice that right now if I turn the knob, that the indicator over here does move. That's not the point of this. So you want to set this back at 30, which is what I'm doing right now. So with the indicator over here set the way I intend to do it every single time. So that's right in the middle of 30 for me. So now I don't want to move the knob, but now I want to bring this collar up. So you can see that I can spin the collar, but it doesn't change the position of the knob here, nor the set tension over here, which is currently at 30. So I'm going to spin this around to bring the little hash, mine's a little beat up here, but there's a little hash mark here next to this 0, and I want to line it up with this hash mark and then lock it into place. So I'm going to hold this with my thumb or my finger and tighten that set screw. And the set screw here just prevents the collar from turning when you don't want it to turn. So now, remember, this is 30. It's set at 30 right now. So that's at 30, and this is a 0. So because you'll notice over here that the next numerical value going up from 30 is 36, and then 42, and then 48, and then 54, and then 60. So it jumps by an increment of 6 numerically. So there's 30 and there's 36. Well, let's say I want to string a racket at 31 pounds. Well, I just turn this till it gets to the 1. So you put your marker over here at 30, and then you turn the dial from the 0, which was perfectly lined up with 30 here. So that's adding a pound when I turn it. So that's 31. And if I turn it to the 2, that's 32. And if I turn it again to the 0, that's 33 pounds. Which there is a little hash mark here, it just doesn't have a number. So there's a hash mark here for 30, then there's a hash mark with no number, then the next hash mark would be 36. So you'll notice that by rotating this dial, you increase or decrease the tension by 3 pounds, 1 full revolution. So if you go from 0 all the way back to 0 again, you've increased it or decreased it by an increment of 3 pounds. So right now, even though there isn't a 33 on the scale over here, there is a hash mark and my line is lined up. So we were at 30 and we went a full revolution on the knob. We're now at 33, which means if I turn it to the 1, that's going to be 34 pounds. That's going to be 35 pounds. And if we come back to the 0, that's 36 pounds. And if you look over here, you'll now see that that white indicator is lined up with the hash mark and the number 36. So if I want to go to 40 pounds, I can either start at 36 and then go 37, 38, 39, 40. Notice that that is out of 1 because the hash mark that's between 36 and 42 would be 39. 36 plus 3 is 39, so plus 1 more pound. So that's where 40 would be represented. Another quick way you could do it is to just look over here, put it on the 42 to begin with. So if you line that up with 42, then you turn it the opposite way to reduce it. So if that's 42 when it's at 0, that's going to be 41, and that's going to be 40. So you're reducing it by 2 pounds from the 42 that you started at. So you use this as a reference point and then go up or down in increments of 3. So for example, 50 pounds. You'll notice over here that the 50 is not printed either. There's a 48 and there's a 54. So if I go back to, so if I just focus my eyes here and I bring this up to 48 quickly and put it right on 48, and when it's right on 48, this should be on 0. So this is on 48, that's on 0. So if that's 48, that's 49 pounds, and that's 50. So that's now at 50 pounds. And the 60 is actually printed, so 60 is easy to find. And you're probably not going to be stringing a lot higher than 60 these days. So that's 60 there. Notice again that that's on 0. So whenever this indicator lines up with one of these printed numerical values, this should always be a 0. So for example, there's 78. Or let's go all the way up to 84. So if I just watch this indicator, line it up with 84, this should be back to 0 over here. Even though I'm not looking here, I'm paying attention. So I crank this all the way up to 84 pounds. And if I line up the white line by the 84 and the white line on the indicator and make it nice and even here, and I check over here, that's at 0. So this is always at 0 when it's on one of these values here. And then the 1 and the 2 allow you to get two values in between. So that's how you actually make your adjustments to get to whatever tension you want. So if you want 55 pounds, you can go to the 54 mark right there. There's 54, there's the mark, that's on a 0, so that's 54. I turn it, that's 55 pounds. So that's how you actually adjust that. So now I'm going to move the camera so that you're not, so now that we've got that adjusted and this all corresponds the way we want it to, I'll show you how to make the adjustments. I'll show you how to make the adjustments up here on the tension head itself so that the reading on your calibrator matches the reading on your scale or on your indicator down here. Okay, so next you need to know which screws on the actual tensioner make the adjustment for calibrating. There's two screws that you need to know about. This one right here, which you're going to need 2 hex wrenches. The hex wrench that fits this screw, which is the actual adjustment screw that controls the calibration, is a 3mm hex wrench. But before you can turn that clockwise or counterclockwise, it's locked in place by a set screw right here, and this is a 1.5mm hex wrench. So take the 1.5mm hex wrench and loosen this set screw by turning it counterclockwise. Just a few turns so that you'll then be able to adjust this one. So in a moment I'm going to zoom out so that you can see everything all at once. But this is the screw that I'll be adjusting to calibrate the machine. And the tiniest little turn of this screw, it's very sensitive, so that an eighth of a turn on this screw will change your readings quite considerably. So when we do adjust this screw, we'll be adjusting it in very small increments. And when we finally have the tension on the calibrator, let's say 30 pounds, when this is set to 30 pounds and the calibrator is reading 30 pounds, we don't want to adjust that any further. That's when we will tighten this set screw to hold that in place. And then we'll be checking 40 pounds, 50 pounds, 60 pounds, and so on and so forth. So you don't even have to check 30 pounds really, unless you're using, if you're stringing badminton rackets, squash rackets, racquetball rackets. If you're down in that low tension, or you're stringing your tennis rackets really low, you might just skip over the 30 pounds and just check it at say 40, 50, and 60 and call it done. So I'm going to zoom out in a minute, but I just wanted to show you that this is the adjustment screw for the actual calibration, and this is the set screw that holds it so that that doesn't inadvertently move. So if your machine happens to be pulling, let's say you get a calibrator and you realize, wow, I've had this set at 50 pounds, yet the calibrator is showing 60 pounds. So you've been over pulling by 10 pounds and you didn't know it, and you want to adjust it to, it's going to take not that much of a turn here. So maybe check your set screw. Maybe your set screw is not in and tight, and it's allowing this to migrate or move. Whenever you move a machine around, let's say you just you changed residences or something like that, and you had to pack up your machine, or anytime you're moving it around, things can happen. The spring on the back could be worn out. There's a number of things, but if you're pulling under or pulling over what this is set at, it doesn't take much movement on this screw's part to alter your actual pulling tension. So if you've got a vast difference, let's say 15, 20 pounds, you thought you were pulling at 50 pounds, but you find out via the calibrator that you had only been pulling at 35 pounds. It's not much of a turn on this screw could explain that. Likewise, if you thought you'd been pulling at 50 pounds and you realized that you were pulling at 65 pounds, again, maybe this screw moved just a little bit as you were moving the machine around or what have you, or maybe this set screw wasn't tight to keep this from moving around. So let's zoom out and take it all, put all these pieces together. Okay, now we're going to see how all of those pieces and components work together. So I've set my tensioner to 40 pounds. So I want to be stringing my racket at, let's say, 40 pounds. So the back of this is set to 40. And let's check with the calibrator. Now what I've done is I've intentionally taken my crank out of calibration. So I used that 3mm hex wrench and I turned this adjustment screw clockwise, which made the tension go down. In other words, even though this is still set at 40 pounds, this is going to read something less than 40 pounds. If you turn this clockwise, it's going to make the calibrator less. The real tension will be less than what it's set over here on your dial. And if you turn it counterclockwise, it'll do the opposite. So before I show you how to adjust it, let's go ahead and pull tension here and see. So we think that this is set to 40 pounds. Well, it is set to 40 pounds. We're hoping that this will be 40 pounds, let's say. So let's check. Now that we know how to do all of this, we're going to turn this and see what it reads at the moment it hits lockout. And I know you can't see it, but it's not even 35 pounds. It's more than 30 and it's close to 35, but I couldn't actually see the little white hash mark where the 35 would be. So it's pulling, let's say, 34 pounds, 33 pounds, according to our calibrator. So we know that we want to make an adjustment so that this goes up and gets close to 40, which we have set over here. So we just release it from the tension head, take the 3mm hex wrench, and we're going to turn this counterclockwise just a tiny bit. So I'm going to turn this maybe a quarter of a turn, and then we're going to check again. And let's see if I can even see. Okay, so it went past the mark that indicates 35 pounds, but it is not quite to 40. I can see the edge of the actual 4, the digit 4, but I never actually saw the little white hash mark. So we're close, but not quite there. So release the calibrator. We're going to make another adjustment, again turning it counterclockwise, but this time not a quarter turn. That'll be way too much. Let's just turn it a little bit, maybe almost an eighth of a turn, and do another check. And it's important that I'm staring at this, as I said before, right at the moment that it hits lockout. I want to see if I can see that white line. I know that you can't see it based on the camera angle, so you have to take my word for it. But I'm staring right here. And that might be a little bit over. I can definitely see the white line. So I'm going to actually go back in the other direction. I'm going to adjust that screw clockwise to make that go down a little bit. So I'm just going to give that a tiny little nudge and recheck it. And now I just can't see the white line. So we're going to go back the other direction, just a hair. So let's take a look. And that's perfect. And like anything in life, don't take just one reading as to be correct. Release the tension and try it a couple times and see if you're getting the same thing happening each time. So let's take another one. It should be right on the 40. And it is. So now we know that this is set to 40 and we're getting 40 on our calibrator. So right now it is calibrated. And in theory I could go ahead and take my little 1.5 millimeter hex wrench and tighten down that set screw. In fact, here, I'll go ahead and do that. I was going to wait and do that at the end, but I'll go ahead and tighten this down and hopefully we won't have to change it again. So I'm just going to tighten this little set screw. So now we're going to try other tensions. So come over here and change it. Let's say we're going to go up to 50 pounds. So we had it at 40. That's 45. We could check 45, but I'm going to go ahead and go up to 50. So that's spot on 50 pounds over here on our indicator. Let's see if the calibrator is revealing 50 pounds on the actual pull. And perfect. So maybe if it's not too much trouble, I might zoom in the camera here so that you can see the readings here. But let me check 60. So that's exactly 60 pounds over here on the machine. Let's see if we're pulling 60 pounds. And I can just see the white line, the hash mark there at 60 pounds. So that's how you calibrate a gamma, lockout, or crank machine. So I think I've covered all of the important aspects of how to set up the turntable, how to come out of the string clamp, how to set the base clamp. I already tightened that set screw, so I don't have to go back and do that. So now this screw shouldn't come out of adjustment because the set screw is tightened up and it's pulling 40 pounds. When I set this at 40, it's pulling 40. When I set it at 50, it's pulling 50. When I set it at 60, it's pulling 60. And that's consistent across the board. And I already covered how to adjust that little collar so that your zero lines up when you have it, when your scale is at 50 pounds or 60 pounds. In this case it's at 60 pounds and this dial is actually at 0 because 60 is one of the numbers on the scale. So if I've left anything out, just leave a comment or send me a question. Hopefully I've covered all the bases. Oh, we have one last thing to cover, which is removing your crank from the bar and installing a Weiss tension head. So I'll cover that real quick. Okay, so here's the part about how to install a Weiss tension head. Because people ask all the time when they're contemplating buying a Weiss, is it easy to install on my crank machine? It's extremely easy. So when you open up your Weiss, the tensioner is all put together. Here's the tension head, and the Diablo, the gripper, all of this is already on there. The only thing that's not attached, the only thing that's on here right now that isn't attached when you remove it from the box is this bracket down here. So this bracket, which is held on by 3 screws on the back, you do have to put that on. So there's also a little screw here. This is what actually holds it on the track and keeps it from sliding. So you can see through this this bracket here, it slides onto pretty much, to my knowledge, any tensioner bar here. So the only thing you have to do is take this out of the wrapper, take the packaging, open it up, and put this in place and tighten 3 hex bolts here, and that just stays on there permanently. So this slides on, so this is ready to slide right onto the bar of any machine. Now, if you have a gamma machine, you can purchase, or my machine, my Weiss head came with it, is the so-called gamma adapter. You can see mine's still wrapped in plastic. I've never even unwrapped it. I've never used it. You can use this. All this is it's a spacer. If you're going to use this, you put it, this piece goes on first and is held by these 3 screws, and then this bracket would be 2 inches down, because this is basically 2 inches wide. So this piece would go in between the standard bracket and the actual Weiss unit if you use it. And the reason for this is it will basically elevate the top of the tensioner 2 inches higher than it is when you do it this way. So I've never used this. I'll show you in a moment. So you have to take the crank off first. I don't have my, there's one little screw that goes on the end here that has a little washer. I don't keep mine on there. I removed it long ago because I'm constantly taking this on and off of the bar as I travel. So normally there's a little Phillips head screw here and a small washer that prevent, and the reason it's there is it prevents your crank from going right off the end of the rail. So it creates a stop so that this can't go too far, and the cog won't come disengaged from the teeth here on the track. So basically its travel is limited between that screw at the end and the screw here, the stop screw here. So you remove that screw and that washer from the end, and this goes all the way off of the track. So you just remove this, and now with that screw and that washer still missing from here, now you can reposition this if you want. It just depends on what you want to do. You now slide this bracket onto the bar like so. Now if you want to be able to slide it any further than there, if you want it to hit the stop where your crank used to stop, you can leave that screw oriented like that. And I don't know what the distance from the racket to here is because I don't leave mine there. I like my Weiss head to be closer. So I actually I pull the knob out and reset it 90 degrees so that this can slide beyond that point and get a lot closer to the racket. So the only thing that holds this on the track is that single hex screw that I showed you right here. I think more recent models might have 2 screws. I'm not sure about that, but this one, mine is old enough that it still just has 1 screw. So obviously that screw needs to be in place, but not all the way in. So just have that screw ready to tighten. Slide it on. And I like to put mine about there. And then all I have to do is take a hex wrench to that screw, make sure everything's level, and tighten it up. And once that screw's tightened, that's it. You're done. I mean, you can put that little washer and screw still back here on the end of this bar if you want to, or you can leave it off permanently the way I do. So that's how easy it is. So if you set it up this way with the standard bracket only, and you don't use the gamma adapter, then you're going to maintain 360 rotation. So when I mount a racket on here, I'll be able to spin the racket all the way around and it never hits the tension head. So your pulls, the string angles slightly downward from the grommet, from the edge of the frame to the Diablo, and goes into the gripper. If you do choose to implement the gamma adapter, then this Diablo and gripper, the whole assembly, is going to sit 2 inches higher, which means that the string essentially pulls straight out of the grommet, at least for most frames. Once you've got a frame mounted, because the plane of the string bed right now is about 2 inches higher than where this gripper is. So there's a slight angle down of the string on each pull. If you implement this, this is going to be 2 inches higher, and the pull will be almost parallel to the floor. It'll almost be on the same plane as the string bed itself. So you'll have a little less friction at the edge of the frame where the string enters and exits the grommets. But your tension head will be in the way, so when you pivot your turntable around, you'll have to make sure that you don't whack the racket or the handle into the tension head, so you won't have 360-degree rotation. So whether or not you choose to use this will largely depend on whether or not you want to maintain your 360-degree rotation with a mounted racket on there or not. So I prefer to keep my 360 rotation, hence why I've never even opened this. So that's how easy it is to install a Weiss tension head onto a crank machine. It's just slide one off, slide the other on, tighten a hex nut, and you're ready to go. And so that's how to install a Weiss, how to remove a Weiss, how to install your crank tensioner, how to calibrate the tensioner. I think I've covered everything. If you've got any questions or comments, feel free to ask. Hope that helped you out. Take care.